Is screen visible for everyone?
Yes, sir.
Okay. So, first question. I would ask easier question. You have to answer topic wise, not the answer, exact answer. And what I'm trying to say is, for example, Arpit, what is hyperconjugation? Just give me a quick summary of hyperconjugation, Arpit. Pratigya, quick summary of hyperconjugation.
मतलब ट्रांसफर ऑफ सिग्मा बॉन्ड एंड
हाँ हाँ, ट्रांसफर
अल्फा
ऑफ सिग्मा
कार्बन
बॉन्ड,
ज्यादा होगा तो अल्फा कार्बन ज्यादा होगा तो स्टेबिलिटी ज्यादा होगा
more number
और
of
डिस्टेंस
alpha,
इंडिपेंडेंट
more number of alpha carbon or more number of alpha hydrogen.
डिस्टेंस इंडिपेंडेंट होता है
Distance independent. What else? Distance independent. No bond resonance. Carbon should be
सर और
alpha
क्या
carbon should be
बोल दिए
sp3.
नहीं थे
Hmm? Alpha carbon should be sp3 hybridized, and more number of alpha hydrogen you have, more will be the hyperconjugation. Okay, so these are the points. Hyperconjugation is a electronic effect where electron will move from the sigma bond. This is also known as no bond resonance because one bond will be broken, also known as Baker and Nathan effect. In this case, example, if you have this carbocation, carbon next to this is alpha carbon and hydrogen attached to this alpha carbon are alpha hydrogen. More the number of alpha hydrogen, more will be the stability. Okay. So, if anybody asks what is the criteria of hyperconjugation effect, so answer would be in next to the sp2 hybridized carbon, there should be sp3 hybridized carbon, and this sp3 hybridized carbon should have alpha hydrogen. Alpha hydrogen must be there. sp3 hybridized carbon must be there. In first situation, what happens? Uh, Barinder, example this question. These two carbons are sp2. Correct?
Yes, sir.
Next, next to this carbon will be the alpha carbon. Do you have alpha hydrogen in this case? Barinder,
No, sir.
no. So we do have alpha carbon but not alpha hydrogen because methyl groups are occupying this space. That is why hyperconjugation is not present here. Sandana, next, do you have hyperconjugation in the second molecule? Sandana, Sandana, am I audible?
सर वो तो क्लास
नहीं है. Tania, do we have hyperconjugation in second topic?
हाँ सर नो सर
Arpit, are you there?
हाँ है
Hyperconjugation होगा second option में.
वैसे
हाँ. How
इस पे
to get idea कि whether there is a hyperconjugation or not? जितने भी बेंजीन रिंग में कार्बन होते हैं वो सारे sp2 हाइब्रिडाइज। कैसे पता चला? क्योंकि उनमें कार्बन कार्बन का डबल बॉन्ड। ऑल द कार्बन इन benzene ring are sp2 hybridized carbon because they have double bond. Okay? So carbon next to this will be the sp3 hybridized carbon. Correct? Carbon next to this will be sp3 hybridized carbon, and these three hydrogen will be alpha hydrogen. Next, what was our criteria? You should have one sp2 hybridized carbon next to this sp3, and this sp3 carbon should have alpha hydrogen. These were the three criteria. Correct. One should have sp2, second sp3 carbon, and last alpha hydrogen. In first option, you were not having alpha hydrogen. Second option, yes, we do have. So this is hyperconjugation. Third, Pratigya, do you have alpha hydrogen in this case? Pratigya,
No.
Yes, sir.
no. Why? Because we do have
नहीं
sp2
है
hybridized
जरा
carbon
नहीं.
because of the ring, but after that there is no sp3 hybridized carbon. So not possible here. Same. This is the sp2. Next to this is sp3, but you don't have free hydrogen.
सर अल्फा
Correct?
हाइड्रोजन भी
So
नहीं है यहाँ पे।
hyperconjugation, हाँ अल्फा हाइड्रोजन नहीं है, इसलिए यह हाइपरकंजुगेशन नहीं है। Right? Now you ask me, do you have any question from hyperconjugation side? What is hyperconjugation? How to identify hyperconjugation? And last and most important point कि more number of alpha hydrogen, more stable will be the compound. और यही most commonly asked question है। This is the most commonly asked question कि अगर अल्फा हाइड्रोजन ज्यादा होंगे तो स्टेबिलिटी ज्यादा होगी। और मैं लिख के देता हूँ, you will 100% get this question. Which compound is more stable? You have to look for alpha hydrogen. Okay. Arpit, what is the rule of anti-aromatic compound?
एरोमेटिक
हाँ, anti-aromatic compound. What is the rule?
मतलब साइक्लिक होगा।
हाँ, cyclic होगा। Channa, am I audible for you?
Yes, sir.
Okay. हाँ, so Arpit, anti-aromatic compound, cyclic,
प्लानर होगा,
planar होगा,
एक प्लानर कॉन्जुगेशन होगा उसको,
conjugation होगा, cyclic, planar,
और
conjugation. हाँ,
क्या हेकेल रूल में जो फॉर्मूला होगा 4n पाई इलेक्ट्रॉन।
हाँ, 4
इतना
and
तो
5 electron.
हाँ।
Correct. So these are the rule, guys. Remember, what is the difference between the aromatic and anti-aromatic? So in case of aromatic and anti-aromatic, everything is same except one, Huckel rule. Everything is same except Huckel rule. How? Both are cyclic rings, right? Both are planar. Chandana, what is the meaning of planar? Both have resonance or conjugation. Chandana, fast.
Hello, sir. Can you hear me?
Yes, I can. Yes, Chandana. I think Chandana has some network issue. Tanya, what is the meaning of the planar compound? Tanya,
Sir, all the carbon are forming bonds in the same plane.
same plane, correct? And this is
sp2
sp2 hybridized carbon. So, okay. Cyclic means there should be ring. Planar means there should be sp2 hybridized carbon. Best example is benzene ring. In benzene ring, all carbon are sp2. That's why they are planar. Resonance should be their conjugation, and Huckel rule is the most important rule for this aromatic compound. 4n plus 2 and could be the number of rings and could be 0 to 1, 2, 3, 4, any number of times. What is anti-aromatic compound? Same as aromatic, except you have
0
4n pi electron, not 4n plus 2. 4n pi electron, not 4n plus 2. Remember this, not 4n plus 2. Okay? And non-aromatic, if any of these criteria is not followed, then it is non-aromatic compound. Example, they are not cyclic or planar or resonance is not there, then they are non-aromatic compound. Okay, come to this question again, and this is the point. While we are solving in the class, you will always feel we are going slow. Yes, it is slow, but we are revising whole thing. Even if you didn't do this topic, you can still revise it here. First option. Which of the following is not anti-aromatic? For anti-aromatic, all four are cyclic compounds. So first criteria is fulfilled in everyone. Second, uh, Arpit, you said planar, right? Planar means
yes
sp2 hybridization. We have to check. Here,
मतलब
if you see,
सर मतलब एवरी कार्बन इसमें क्या होगा
uh,
मतलब क्राइटेरिया
every element should have um, sp2 hybridized carbon. Example here, each carbon have double bond, so sp2. Each carbon have double bond sp2. Each carbon have double bond sp2. But in the first option, what do you have? Nitrogen is sp3. Correct?
हाँ
Nitrogen is sp3. So it's not aromatic or anti-aromatic. It is non-aromatic. Okay. So because this is not following the second rule of planarity. Planar. Got it?
सर, एक हेट्रोसाइक्लिक रिंग कभी एरोमेटिक हो सकता है?
हाँ, हो सकता है बिल्कुल. अगर इसके ऊपर मान लो इलेक्ट्रॉन होते और वो डबल बॉन्ड के साथ जुड़ा होता, तो मान लो यहाँ पे होता डबल बॉन्ड. पायरिडीन देख लो. पायरिडीन में is this, if you have this and this, you have electron, non pair electron in this, and it can be hybridization sp2. Ring, yes, it is there. Resonance, yes, it is there. So it is showing the aromatic nature, isn't it? Without.
नो सर.
Okay, next question. Here will take less time because this is again um, part of inductive effect as well as hyperconjugation effect. Pratigya, tell me, if you have electron donating group and electron withdrawing group, how they are going to impact the stability of the compound carbocation? Pratigya.
हाँ सर, इलेक्ट्रॉन डोनेटिंग ग्रुप इंक्रीज करता
Electron,
है.
correct. Electron donating group increase stability. कैसे? देखो, stability means less energy, right? Energy should be less. And how to get idea whether a compound is more stable or less stable? One of the best criteria is charge. If any compound have less charge, it will be more stable. Remember this. Less charge, more stable. Less charge, more stable. Doesn't matter whether it is carbocation or carboanion. Less charge is always more stable. Now, you have to understand here we have carbocation in both the situations. But in first one, there is a electron donating group, EDG, electron donating group. This electron donating group will donate electron to the carbocation. It will try to gain some negative charge. Negative charge is neutralized by the positive charge and charge will reduce. Make sense? The most correct. Electron donating group increase stability of carbocation. How? By reducing charge. So first option, it have plus I effect, no doubt, and increase stability. Yes. So, Barinder, what is inductive effect?
Polarization of sigma bond.
Correct. Polarization of sigma bond. What else? Complete detail of inductive effect. This is correct. I'm doing this for everyone who did not attend this topic class like inductive effect, hyperconjugation. So whenever you have a carbon chain and some atom or molecule attached to it and have electronegativity difference. So what will happen? Either this molecule can have positive charge and carbon can have negative, or ulta is also possible. This molecule have negative charge and carbon have positive. There are only two possibilities. But due to electronegativity difference, what will happen? Electron will try to move in specific direction. Displacement of electron. Displacement of electron. Example, if it is halogen like chlorine, so chlorine will withdraw electron toward it. So any molecule that withdraw electron from the carbon chain is electron withdrawing group and show minus I. So it will show minus I. Okay. So electron withdrawing group show minus I effect. And electron donating group will donate electron to the carbon chain. So it will show plus I effect. Remember this. This inductive effect is distance dependent. It means on the first carbon you can feel the difference. On fourth carbon it will be negligible. Correct? It will be negligible in case of fourth or more than fourth carbon because it is distance dependent. That's all. Now, if you know inductive effect, this topic will be extremely easy for you to understand. Plus I, yes, CSP group donate electron, so it increases stability. Second, uh, Chandana, hyperconjugation interaction will increase stability of this. Is this correct?
Yes, sir.
Yes. Why? Because this carbon is sp2, next carbon is sp3, and sp3 carbon have alpha 3 alpha hydrogen. So that is also possible. Arpit, third option. Carbon hydrogen sigma bond help dispersing positive charge. In case of
Yes,
hyperconjugation, is this correct? Yes. In
yes,
hyperconjugation, positive charge will spread. So positive charge will spread. It means charge will be. It is same like take example लेता हूँ. You have to give money to someone. like you have to repay the loan. If you have many supportive person, तो वो loan disperse हो जाएगा and you will have less burden, more stability. Correct? But if you have to pay loan and you are the loan person, कोई नहीं है support करने वाला, you are a lone person. So what will happen? You will have more mental stress, less stress. So what happen in case of electron donating groups? You will see there will be spread of the positive charge and spread of positive charge, less positive charge on carbon, less charge, more stable. Tanya, last option. Electron of carbon hydrogen bond can be delocalized into empty 3p orbital. Tanya, 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 आवाज आ रही है?
कुछ भी होगा।
Not there. हाँ, फिर कुछ बोल रहे थे। अर्पित,
जी जी जी।
हाँ, तान्या, you are there? हाँ, अर्पित आंसर बताओ, क्या ये सही है?
टोपी होगा ये मतलब शायद।
Exactly, 2p होगा because in carbon, if there are 6 electrons, how you fill 1s2, 2s2, 2p4, 2p2, sorry, right?
हाँ
Total 6 electrons. So
yes,
empty 2p orbital are involved in the localization of 3p. That's why this is the answer. Resonance effect. Chandana, what is resonance effect? Chandana, Barinder,
Yes, sir.
what is resonance effect?
Delocalization of pi bond.
Exactly. The localization of pi bond or pi electron. The more the resonance structure, more will be the stability. Resonance structure is also known as canonical structure. Okay. So more number of canonical structure will increase the stability. Okay. So if canonical structure is more, stability will also be more. So first statement is absolutely correct. Pratigya, second, energy of the actual structure is lower than canonical structure. Yes. Why? Any canonical structure, any canonical structure will have more energy and less stability. And resonance hybrid actual structure will have less energy and maximum stability. Okay? So actual structure always have less energy and more stability. Arpit, third option. Difference in the energy of the highest canonical structure and lowest canonical
yes, yes,
structure is
करेक्ट है,
reduced.
करेक्ट है, करेक्ट है। मतलब ये है ना,
Resonance energy is the energy difference between the given canonical structure minus resonance hybrid actual structure. Okay, resonance hybrid और canonical structure के बीच में जो energy difference होता है, that is resonance energy. not lowest element. This word is wrong. Okay. Chandana, last option. More number of canonical structure, more is the resonance energy.
Yes, correct.
Okay. More number of canonical structures means overall energy will be more. How? Because example, if you have one canonical structure and you have 10 joule energy, if you have 10 canonical structures, then each having, let's assume 8. 8 multiplied by 10 energy will be more. Yes, but remember, more canonical structure, resonance hybrid will be more stable. Okay, so this option is also correct. Next, तानिया, आवाज आ रही है मेरी?
Yes, sir.
हाँ, so टोटोमेरिज्म पढ़ा है तुमने अभी?
हाँ सर.
बताओ कुछ टोटोमेरिज्म के बारे में.
सर वो एक तरह के फंक्शनल आइसोमर्स होते हैं.
Kind of functional isomer, okay. Then in this case of tautomerism, can we say कि keto form convert into enol form? Hmm? Keto form convert into enol form like this, right? Keto enol form. Question is, this is also known as desmotropism. Tropism. Right? Question is, what is the criteria of tautomerism? Arpit. Criteria of tautomerism. This is most important question from tautomerism.
याद है.
If you take ketone, example this, so you know this is functional group. Carbon next to this carbon is alpha carbon, right? Carbon next to the functional group are alpha carbon, and hydrogen next to this will be alpha hydrogen, correct? So two major criteria is, first, you should have alpha carbon, and this alpha carbon should be sp3 hybridized. Okay, and second, there must be alpha hydrogen. Got it? Only then what will happen? Electron of this oxygen will transfer here, and hydrogen, alpha hydrogen, will go to this, and it will form enol. Any doubt, anybody? What is tautomerism? Okay, so two criteria: alpha carbon should be sp3 hybridized, and there should be alpha hydrogen. Example: first question is first option is really good. This is functional group. Carbon next to this are alpha carbon, but they have sp2 hybridization. Then you can check next carbon, ortho or para. Para is sp3. So this will be alpha carbon, and two hydrogen are present here. Those will be two alpha hydrogen. Tanya, any doubt?
No sir.
So everybody, guys, carbon next to R alpha carbon, if it is not present, then you can check para position also. Okay? Para position also. Very important thing. Chandana, in case of second question, second option B, do you have alpha carbon, which is
No,
sp2 hybridized carbon? No. This is sp2, not sp3. This is sp2. Here you don't have carbon,
Yes.
so this is not possible. Barinder, C option.
इसमें है sir.
Very good. Correct. Either. Here you have two hydrogen. This carbon is alpha carbon and this is sp3 because not attached to any double bond. So sp3. So what will be the answer? A and C. Okay. And this is what
मैं
I'm
ये सी वाला फिर से
क्या
सी वाला सी वाला है
C?
सी ऑप्शन
हाँ हाँ
फिर से बता दीजिए
बिल्कुल. See, first we have to look for the functional group. ये functional group है जहाँ पे ketone present होता है ना? Wherever we have ketone, it is functional group. Carbon next to the ketone carbon is alpha carbon. This is alpha carbon. This is also alpha carbon. Right? Both sides are alpha carbon. But on the upper side, this carbon have sp2 hybridization, and this carbon is not connected to any double bond. That's why it is sp3. Correct. And last thing, this carbon will have two hydrogen because tetravalency of carbon should complete, right? So if you complete the
Yes.
tetravalency of carbon, two criteria of tautomerism is alpha carbon should be sp3 and there should be alpha hydrogen. These are the two criteria. अब ऊपर वाला तो जो कार्बन है वो sp2 है, so it is not fulfilling. Upper carbon is not fulfilling tautomerism. Lower carbon can. How do we get idea? Carbon have four bonds, two are already present, two will be the hydrogen. Arpit, कोई doubt?
सर अगर दोनों कार्बन sp3 होगा तो कैसे करेंगे मतलब
तो अच्छी बात है. There will be more resonance.
वो कोई भी साइड से ले सकते हैं चेक कर सकते
हाँ,
हैं
you can take both sides. Example, अगर ऊपर वाले केस में if you don't have double bond, ये है ही, it does not exist. So this carbon will be sp3 and here also you can have tautomerism. It is good. Correct. Example is example if you take this acetone, here you have alpha carbon on both these sides. It's good. Both are sp3 and 3 alpha hydrogen total 6 alpha. Good, no problem. On both sides it can undergo tautomerism. Okay. This is what initially in first 10 question we will take time. After that we will run fast because हमारे सारे टॉपिक्स रिवाइज हो चुके होंगे. नेक्स्ट प्रतिज्ञा 51st क्वेश्चन. Decreasing order of pKb. What is pKb?
basic
बताइए.
strength.
हाँ. What is pKa and pKb?
पीके मतलब एसिडिक ऑर्डर बेसिक ऑर्डर.
Correct. For acid you use equilibrium constant Ka. For base you use equilibrium constant Kb. Like for acid you have H positive ion. For base you have OH negative ion. Right? If you have H positive ion, how you show pH? Power of hydration pH is equal to minus log of H positive concentration. Right? Equilibrium factor. Say way you can calculate POH minus log OH negative concentration.
14 से भी तो नेगेटिव मतलब माइनस कर सकते हैं
हाँ,
सब्ट्रैक्ट
14 से
कर
माइनस
सकते
कर सकते हैं. If you know pH and if you know POH, you can get pH here again. We can do. 14 लो, उसमें से माइनस कर दो, you will get the answer. Same way, if you have Ka, power of Ka will be minus log Ka, and power of Kb will be minus log Kb. Any doubt? Anybody have doubt in this? There are many people who know that sir, if Ka is more, Pka will be less. If Kb is more, Pkb will be less. It means they are inversely proportional to each other. They know this topic, they memorize it. But if I ask them, tell me what is pKa, they can't answer. That's why I told this PH and POH method. And once you understand this from equilibrium chapter, after that everything become easy and you should know one thing. Patiga, electron withdrawing group will increase what? Acid character or basic character?
Basic character.
Very good. Acid character, electron withdrawing group will increase. So Ka will be more. If Ka is more, Pk is ulta, Pka will be less. If acid character is more, then definitely basic character is less. Basic character less, Kb will be less. And you know it is inversely proportional to Pkb, will be more. Any doubt, guys? Arpit, Sania, Chandana, because you didn't attend this class. Any doubt?
No, sir.
No, sir.
Okay. So, based on that example, if acidic character is more, then H positive concentration will be more and pH will be less. Same here. If you see basic character, then if basic character is decreasing, then OH concentration will be less, correct? And if OH concentration is less, then what will be the POH will be more. Any doubt? Same way, ditto same way. Right? Electron donating group, ulta. Electron donating group will decrease acidic character and increase basic character. If you understand this from class 12, your alcohol phenol ether, aldehyde ketone carboxylic acid, and amines, acidic and basic character is done. That's all. Only one thing. Electron withdrawing group increase acidic character. That's all. Now look at this. Actually, this is from the amine chapter. Amine chapter. You know, in case of amine, you talk about Kb, and Kb is inversely proportional to pKb. Is there asking decreasing order of pKb? So now you tell me, Sania, इलेक्ट्रॉन डोनेटिंग ग्रुप का क्या इफेक्ट होगा केबी के ऊपर?
सर केबी इंक्रीज होगा.
इलेक्ट्रॉन डोनेटिंग ग्रुप की वजह से बेसिक कैरेक्टर इंक्रीज होता है तो केबी इंक्रीज होगा. वेरी गुड. पीकेबी क्या होगा?
सर डिक्रीज होगा.
डिक्रीज होगा. एंड उल्टा इज पॉसिबल इन केस ऑफ इलेक्ट्रॉन विड्रॉइंग ग्रुप. चंदना?
So KB value decreases,
केबी डिक्रीज एंड पीकेबी विल
KB value increases.
increase. Correct. Now you compare. Example here you have electron withdrawing group NO2, right? So can you say this electron withdrawing group will increase pKb value? So it will be the highest. So answer to it will be second. Easy to do, right? Example here You remember this, even benzene rings have resonance, so it decreases basic character. Okay, so compared to aniline and this part, this one will have maximum basic character because direct alkyl group is attached to the NH2. So one will have maximum basic character and minimum pKb. Right? So answer हो गया. But what I feel, this option 2 and 3 given wrong. Why? This is normal alanine. Here you have electron donating group, ethyl group, and electron donating group increase basic character. And if basic character is increased, then pKb value will decrease. Right? It means 2 is more basic than 3. Then 3 will be having more pKb value. Oh, sorry, it is correct. This is correct. What my point? In 2 and 3, how to get idea? Electron donating group increase Kb value and decrease pKb value. That's why 2 is lesser than this. Any doubt? And you will get this kind of question even for the acidic character. Like, Barinder, tell me, if you have this molecule and not 2, and if you have this molecule, which will be more acidic?
First,
Everybody can answer this question. First will be more acidic.
So second one will be more acidic.
Second one will be more acidic. Okay. So 2 will be more acidic than 1. Okay. So Sanya, your answer is 2 is more. Barinder, your answer is 1 is more. Chandana, Arpit, and Pratigya.
So 2 is greater than
2 is greater than 1. Arpit and Pratigya.
1 is greater than 2.
1 is greater than 2. Pratigya. Pratigya fast. Pratigya बोलोगे आजाद में? कन्वेन निकलना है सुबह. Pratigya, are you there?
हाँ
बोलो.
साउंड ब्रेक हो रहा था आपका.
हाँ, शायद क्या साउंड ब्रेक था. तो देखो, इस whenever you see acidic character, then you will know कि electron withdrawing group will increase acidic character. Right? Electron withdrawing group means minus I and minus R. R means resonance. Both will increase acidic character. You know resonance effect at ortho and para is exactly same. So minus R will be same. It means minus I going to decide. Wherever you have more minus I, you will have more acidic character. Make sense, Arpit?
Yes.
So tell me, ऑर्थो पे ज्यादा माइनस आई इफेक्ट होता है या पैरा पे? वेयर यू हैव मोर आई इफेक्ट, ऑर्थो और पैरा?
ऑर्थो में होता है.
ऑर्थो, बिकॉज ऑर्थो इज क्लोजर. आई टोल्ड यू.
हाँ.
कि inductive effect is distance dependent. हाँ, okay, distance dependent. So in case of photo, distance is least, so ortho will be maximum. So 1 should be greater than 2. Correct? Make sense? Sania and Chandana, any doubt?
No,
No,
sir.
sir.
But
Got it.
the answer is 2 is greater than 1. Arpit, Barinder, Bhataya, answer is 2 is greater than 1. You know why? And that is the reason why I asked this question. Hydrogen bonding, intramolecular hydrogen bonding in ortho. That is a special case. Logically, ortho should be more than para because more inductive effect. But answer in reality is 2 is greater than 1. Why? Because acidic character means how easily as positive can leave. Make sense? How easily as positive can leave. But in case of ortho, because of intramolecular hydrogen bonding, hydrogen is not able to leave properly. Make sense? Barinder and Arpit.
सर अगर
Yes.
मतलब OH की जगह COH होता तो क्या होता?
तब भी हाइड्रोजन बॉन्डिंग तो होता. But if CH3, if you have, तब हाइड्रोजन बॉन्डिंग तब भी होता. Hydrogen bonding is the main reason. But if, example, you have another electron withdrawing group X, halogen, then and there is some other molecule in case of OH, and hydrogen bonding is not possible. You know, example, if you take instead of NO2 X, hydrogen bonding is not possible X like iodine. So what will happen? Ortho is more, sorry, para is more. तो ऑर्थो ज्यादा होगा या पैरा ज्यादा, इट डिपेंड अपॉन द हाइड्रोजन बॉन्डिंग. हाइड्रोजन बॉन्डिंग इज रिड्यूसिंग एसिडिक एसिड. दैट इज द सिंपलेस्ट आंसर. ओके, रिमेंबर दिस, highlight this in your notebook. Hydrogen bonding reduce acidic acid. Okay, so this topic is done. 52 is most stable carbocation. Now most stable carbocation, stability means more stability, less energy, less charge. If molecule is more stable, it means charge will be less. Correct? In case of carbon, anywhere carbocation, carbon. So here in this situation, what will happen? Stability of the carbocation are decided by two factors. One is plus I effect, inductive effect, and second is plus R effect, resonance effect and inductive effect. These two are deciding. NH2 molecule is electron donating group, right? It is electron donating group, and you have resonance as well here. In every case, you have resonance. Now, tell me where you will have maximum inductive effect. At ortho, you have maximum inductive effect. But here, positive charge is present either on ortho, meta, and para, right? So, ortho is not possible because first and last are both same, exactly same thing, right? So, it means you have to identify out of para and meta where you will have more stability.
Para, sir.
Hmm. Example, if you take meta position here, so these two electron on meta will go here, it will be double bond. These electron will go here, correct? These electron will go here. And what will happen? This charge is neutralized because it negative will come because of the transfer of electron, double bond, NH2, and this, right? This is stable because you have good amount of resonance in this case. Any doubt? So answer will be 51. 52 का answer will be Pratigya. Any doubt?
सर ए नहीं होगा क्या?
नहीं, ए ए मतलब ए क्या बोल रहे हो? ए वाला वो या
सर ए और
ऑप्शन
डी
फर्स्ट?
में सिमिलैरिटी क्या है?
दोनों एग्जैक्टली सेम ही चीजें हैं, दोनों ऑर्थो पोजीशन पे है पॉजिटिव चार्ज, वो
मिरर
एग्जैक्टली सेम ही स्ट्रक्चर है ए और डी.
ओके सर.
बट अब यहाँ पे क्या होगा? वरिंदर, यू आस्क दिस क्वेश्चन कि सर ए क्यों नहीं हो सकता. मैं ये मान के चला हूँ तुमने ये पूछा है कि फिर ये क्यों नहीं हो सकता है ना. वरिंदर, यही क्वेश्चन है ना?
यस सर.
ठीक है, तो अब बना के देख लेते हैं. अगर ए और डी वाला बनाएंगे तो NH2 donate its electron, this nitrogen donates its electron to this, correct? So like this, and because uh, what will happen, आगे रेजोनेंस ही नहीं हो सकती. बताओ क्या रेजोनेंस हो सकती है? क्योंकि आगे शिफ्ट करने के लिए पाई इलेक्ट्रॉन भी तो चाहिए. You need pi electron to shift and to have the resonance, right? Yes or no? Barinder, बताओ. कोई डाउट? एनी डाउट?
नो सर.
इन केस ऑफ डी, सान्या, तुम्हारा ये क्वेश्चन था ना कि सर वाई नॉट सी. अब डी में हो तो सकता है, NH, this nitrogen will donate its electron and this become double bond. These pi electron will go here, correct? And it will become negative, and here it will be positive, here will be positive. बताओ क्या ये स्टेबल है इतना सारा चार्ज?
नो सर.
Right? And if you see in case of B again, there is no resonance. If you try to give these electron and make it pi, आगे तो है ही नहीं ना, ना तो इस साइड में यहाँ पे है, ना इस साइड में इधर है. You don't have negative double bond on either of the side.
यस सर.
So resonance दो में possible है. You have resonance only in two structures C and D. But in case of D there is lot of charge, less stable. But in case of C, minimum charge, maximum stable. Actually, this is really good question. It is not easy to be honest. Like from student point of view, because I understand कि sir हमें तो समझ में ही नहीं आ रहा ये. Sir, we are not able to understand कि हो क्या रहा है इसमें, right? What is happening? But This is how we solve more number of questions. This is the easiest one. Everybody have to answer. You have to tell me your answer. Chandana, what is your answer for 53? Anybody have doubts from question number 53?
No, sir.
Barinder, Arpit, Tanya, any doubts from 52?
No. 52
No,
या
sir.
53?
52, 52.
नहीं.
No, sir.
Answer for 53 because this is the easiest one. I'll explain electromagnetic effect once, but plus E means electromagnetic effect. So 3, 4, 3, 3. Arpit, Tanya, and Tanay.
Sir, option
Yeah.
4.
Option 4. प्रतिज्ञा आवाज आ रही है? Am I audible? प्रतिज्ञा
हाँ
मतलब
हाँ
question network. Very good. अब आंसर बताओ फिर जल्दी से.
मेरा कनेक्शन कट गया था, मुझे समझ में नहीं, मतलब मैंने नहीं
मैं दोबारा समझा दूंगा 52 एंड में. ठीक है,
हाँ
तुम्हारे लिए सेपरेटली समझा दूंगा. अर्पित 53 का आंसर.
ऑप्शन 4 ऑप्शन 2.
ऑप्शन 4 एंड
4 हो गया 4.
चंदना एंड मरिंदर.
Sir, 4.
Chandana, answer will be 4. Why? Electromagnetic effect means movement of pi electron. Movement of pi electron is electromagnetic effect. Now there are two possibilities of pi electron movement. If electrons move to the same atom as attacking reagent, here attacking reagent is H positive here, H positive here, H positive here, H negative here. These are attacking reagents. Example here. Electron are moving to this carbon, it will get negative charge. Hydrogen will also move to the same carbon. Right? Such kind of effect is known as plus E, plus electromagnetic effect. Same thing here. Here electron will move and H will move in the same direction. Same here. Correct? But in fourth option, when electron move toward the nitrogen, it will have negative charge. Then OH will go to the carbon because it will have positive. If attacking reagent and electrons are moving to the different atom, it is minus E, minus electromagnetic effect. Any doubt? So all of your answer is correct. Because in first three positive molecules, but in last you have negative molecules. Here I'll take very less time because now we covered most of the things. Electromagnetic, hyperconjugation, inductive effect, everything we have covered. Tanya, answer for 54. Now onward we'll take the least time for every question. Tanya, 54.
Sir, the answer will be second option. Statement
Very
1
good.
is false and second is true.
Correct. Why? Because inductive and electromagnetic effects, if they are acting in the opposite direction, then electromagnetic effect is stronger than inductive effect. I mentioned this in note. Electromagnetic effect is stronger than inductive effect. So this is definitely wrong. Hyperconjugation is observed in orthoxylene. Orthoxylene means this. You know both carbon are alpha carbon, both hydrogen will be alpha hydrogen. So you will have 6 alpha hydrogen. So hyperconjugation is possible here. Yes, definitely. You should know what is the meaning of xylene. Xylene is the compound that have two CH2. Okay, so answer is correct. Next, Chandana, Huckel rule again. What is Huckel rule? Chandana, what is your answer? Your voice is breaking, Chandana, a lot.
5 electrons.
So what are the molecules that have Huckel's rule, following Huckel's rule? 4n plus 2 pi electron.
What's it?
Which molecule out of 7 are following Huckel's rule?
First one.
First and seventh is definitely there,
Yes, sir.
right? Then you have to look for the other
Sir,
options.
option 4.
Correct. Option 4 is correct. कौन कौन से molecule में होगा?
पहले वाले में होगा,
हाँ,
फोर्थ में होगा, नहीं
हाँ,
पहले में होगा, फोर्थ में होगा, बी में नहीं होगा,
फोर्थ में नहीं होगा, बी में होगा. Why?
फोर्थ में होगा, फोर्थ में होगा.
फोर्थ में नहीं होगा. You will not have
तो
Huckel rule in
सेकेंड
fourth.
वाले में होगा ना.
Exactly second वाले में होगा. How we get to know? 4n plus 2. It means 4 if n value is 1, pi electron should be 6. See, 1, 2. 2 double bond means 4 pi electron. And 2 from this negative charge. Total 6 pi electron. Huckel rule is following. Third is not possible because 4 pi electron is not possible. Fourth, you have 4 pi electron again. 2 from the pi bond and 2 from the lone pair. Only 4, but you need 6, right? Arpit, any doubt?
No.
In in 6, there are 8 pi electron, again not possible. In 7th, there are 3 ring and value 3. So 4 3s are 12 plus 2, 14 pi electrons. So we have 7 double bonds, 14 pi electrons. It is correct. Anybody have doubt in 55?
No, sir.
No, sir.
Okay. Barinder, 56. Weakest way. Barinder, tell me, the weakest basic case में how electron withdrawing group and electron donating group affect basic character. This is the last question. Barinder,
Yes, sir.
core. इलेक्ट्रॉन विड्रॉइंग ग्रुप का बेसिक कैरेक्टर पे क्या इफेक्ट होगा?
सो जो इलेक्ट्रॉन विदड्रॉइंग ग्रुप है वो बेसिक कैरेक्टर को डिक्रीज करते हैं
वेरी गुड. एंड डोनेटिंग ग्रुप बेसिक
एंड
कैरेक्टर को
डोनेटिंग इंक्रीज करते हैं.
करेक्ट. हियर NH2 is attached to CH2 group, right? Here two CH2 group, two alkyl group. So it means 2 will have more basic character than 1. Any doubt, guys? Arpit, out of third and fourth, which one will be having more basic character? Both are electron withdrawing group.
So first one will be having more basic character.
No, second one, na? Because CH3 group, see, this part is same in both. This CH3 is extra, and this is electron donating group. So electron donating group increase basic character, right?
Yes, sir. Yes, sir. Got it.
Arpit, out of third and fourth, see, NO2 group is electron withdrawing group. CHO is also electron withdrawing group.
थर्ड
Both
वाला
are
ज्यादा
electron.
बेसिक होगा फोर्थ से,
थर्ड वाला ज्यादा
बेसिक होगा फोर्थ से,
कैसे?
मतलब इलेक्ट्रॉन डेंसिटी जो नाइट्रोजन है वो दो नाइट्रोजन है ना, इसीलिए इलेक्ट्रॉन डेंसिटी कम कर लेगा, इसलिए लेस बेसिक।
आंसर तो करेक्ट है, बट एक्सप्लेनेशन थोड़ा सा और बता देता हूँ मैं, ऐड कर देता हूँ। आंसर तुमने सही दिया है। सो fourth will have least basic character. Why? Because in third, electron withdrawing group is attached to an NH2 with the help of CH2, electron donating group. But in fourth, electron withdrawing group is directly withdrawing electron from NH, right? If one person is harming you sitting in the Canada, he can um, like create less impact. But if person is directly coming and hitting you, can create more impact. So CH2 group is creating more impact because it is directly withdrawing electron from nitrogen, right? But in case of NO2, though NO2 is a strong withdrawing group than CH2, but NO2 is withdrawing with the help of CH2, so वो impact reduce हो जाता है. Make sense? So answer is in fourth option, direct withdrawing, less basic correction. In case of third, indirect withdrawing, so more basic correction. Any doubt, guys? So maximum will be 2, then 1, then 3, and least 4. Got it? Any doubt?
So can you explain the last one?
Yes. So last one, you can expect कि सर CH3 ग्रुप भी तो है साइड में, वो भी तो इंक्रीज करेगा, है ना?
हाँ सर.
बेसिक कैरेक्टर को CH3 group is electron donating group, and this electron donating group will increase basic character, correct? But these two electron of nitrogen will be impacted by electron withdrawing group directly. CHO ग्रुप जो कि इलेक्ट्रॉन विड्रॉइंग ग्रुप है, वो डायरेक्टली नाइट्रोजन से ही विड्रॉ कर रहा है, तो ज्यादा इलेक्ट्रॉन विड्रॉ करेगा, ज्यादा इम्पैक्ट डालेगा. इफ इलेक्ट्रॉन विड्रॉइंग ग्रुप इज डायरेक्टली अटैच्ड टू नाइट्रोजन, it will withdraw more electron and it will create more impact and decrease acidic character. But in case of third, though NO2 is a strong withdrawing group, but उसका impact indirect है through CH2. Make sense, Tanya?
Yes, sir. I understood.
So direct answer is here. In fourth, you have direct impact of electron withdrawing group, and in third option, you have indirect impact of electron withdrawing group. Got it? Any doubt?
No, sir.
But again, any doubt? Okay. Pratigya, Arpit, topic. After that, जितने भी तुम क्वेश्चन देखोगे,
No.
whatever question you will see, most of time you will see कि बहुत डायरेक्ट क्वेश्चन हो रहे हैं. Now you can finish the remaining question within, if not half an hour, maximum 1 hour. Okay, Chandra. So if you have a particular question, go through it once again.
सर
Spend more.
सर
Harpit,
मतलब 56 नंबर में जो क्वेश्चन फिर से दिखाइए,
हाँ
फिर से दिखाइए।
56 है ना यही?
हाँ हाँ, जो ऑप्शन
हाँ
4 में जो नाइट्रोजन है वो जो
हाँ
सी डबल वन के साथ रेजोनेंस कर रहा है ना, जो नाइट्रोजन के लोन पेयर है,
हाँ, वो रेजोनेंस करने की वजह से इम्पैक्ट होगा। ये भी मैं
ये भी तो
एक
रीजन
और
हो सकता
पॉइंट,
है, ये भी तो रीजन हो
बिल्कुल हो
सकता है।
सकता है, बिल्कुल हो सकता है। एक और रीजन बता देता हूँ, देखो CH3NH, C डबल बॉन्ड O and hydrogen. This is amide. Okay, and oxygen is directly withdrawing electron from this nitrogen. Point वही है. In case of amide, acidic character is less. In general, acidic character is always less in amide. Reason is same, direct impact of oxygen and resonance. Correct? So there is minus I impact and there is also minus R impact. So both will radiate. Here you have only minus I impact. Tell me. मैंने थोड़ा और एक्सप्लेन कर दिया, पर फिर अच्छा पॉइंट ऐड किया तुमने. So guys, he said कि here we can have resonance. Here in case of amide we can have resonance. So minus I and minus R both will reduce acidic character, sorry, basic character. But in case of third option, there is only minus I impact, not minus R. Got it? Got it?
यस
हाँ.
सर.
So
सर
हाँ
जो ऑप्शन 2 एंड 3 है
हाँ
उसमें हम इलेक्ट्रॉन डेंसिटी से भी चेक कर सकते हैं ना.
हाँ, वहां पे तो देखो डायरेक्ट ही इम्पैक्ट है कि इलेक्ट्रॉन विड्रॉइंग ग्रुप विल डिक्रीज एसिडिक बेसिक कैरेक्टर and another side we have CH3 donating group, it will increase basic character. 2 और 3 को
हाँ
कंपेयर करेंगे तो, राइट? इन वन केस यू हैव डोनेटिंग, अनदर केस हैव विड्रॉइंग, तो उसमें तो डाउट ही नहीं रहता. Doubt, you will get doubt when you have same type group withdrawing. Then you have to compare which one is strong withdrawing, है ना?
हाँ हाँ.
और बताओ. So
नहीं
this is all for this class. Now you have to finish all the 45 questions by today. You will ask in the group, sir, out of these 45, I had doubts from these 2, 3, 5 topics. If possible, I'll try to finish by today. Otherwise, tomorrow I'll take 3 classes. One biology, one physics, one chemistry. I'll tell you timing um, by the end of the day. And every day you will have 3 classes. One more thing कि अब हम एक फुल सिलेबस सीरीज स्टार्ट करने वाले हैं, है ना? और उससे हमारा ज़्यादा फोकस होगा. जैसे हमने आज देखा था ना कि जैसे in case of first question, example, when we were doing 46 question, I told you everything about hyperconjugation. So what I will do, we are taking one question. I will finish theory thoroughly, and then you have to solve question instantly. Like we are going to do full syllabus physics, chemistry, biology question. And but first we will finish this paper. What you wrote yesterday. What I mentioned doesn't matter how much marks you got. You should understand all 180 questions with reason. Okay? Got it? हु इज नॉट हियर? प्रतिज्ञा। Okay. तो अर्पित, कैसा रहा लेक्चर?
रिवाइज हो गए।
रिवाइज हो गया अच्छे से? सानिया,
यस सर।
कुछ वो दिखा कि ग्रोथ की, हाँ कुछ नया सीखने को मिला और रिवीजन हो गया?
हाँ सर, मतलब
तो
कुछ
जना,
कॉन्सेप्ट जिसमें थोड़ा डाउटफुल रहता था वो थोड़ा अभी क्लियर है।
हाँ, इसलिए थ्योरी करने से ये समझ में नहीं आती, जब क्वेश्चंस में आते हैं ना डाउट कि अच्छा ये ऐसे भी तो हो सकता था, फिर आता है कि हाँ, फिर दिमाग खुलता है, दिमाग की बत्ती जलती है। चंदना,
Yes, sir.
like you learned new things through those 8 9 questions. No, not 8 9, more than 10 questions, I guess.
Yes, sir.
How many questions?
I learned new points.
Yes,
शायद 14
12 questions किया हमने, हाँ, but you have to finish all 45 questions by today. And अच्छा अर्पित, एक इंटरेस्टिंग बात पूछूं मैं तुमसे?
जी।
तुमने फिजिक्स का भी लेक्चर अटेंड किया एंड
हाँ
केमिस्ट्री का भी, कौन सा
हाँ,
ज्यादा इंटरेस्टिंग लगा डिस्कशन में?
मैं
कौन सा
दोनों
सही
अच्छा
पढ़ाता
लगा।
हूँ? दोनों अच्छा लगा, तो
दोनों।
तीनों सब्जेक्ट ठीक पढ़ा लेता हूँ।
हाँ, बायोलॉजी तो अच्छे पढ़ा हूँ, जूलॉजी बॉटनी पहले ऑफलाइन में।
हाँ हाँ,
फिजिक्स केमिस्ट्री अच्छे।
क्योंकि कई बार क्या होता है ना कि जब कोई देखता है तो उनको ये बिलीव नहीं हो पाता है कि यार कोई इंसान तीनों सब्जेक्ट कैसे पढ़ा सकता है। एक सब्जेक्ट का एक्सपर्ट बन जाए वही बहुत है, कि तीन तीन सब्जेक्ट का। बट ऐसा नहीं लगता, इट्स मोर अबाउट लॉजिक, कि अगर इंसान को लॉजिक समझाना आ गया कि ऐसे हम क्वेश्चन को अटेम्प्ट करते हैं तो काम हो जाएगा। सानिया, तुमने अभी तक फिजिक्स का लेक्चर नहीं सुना है ना?
नो सर, मैंने अटेंड नहीं किया फिजिक्स का।
हाँ, तो कल हम फिजिक्स अटेंड करेंगे, ठीक है?
ओके
सर
सर।
फिजिक्स पेपर डिस्कशन कब करेंगे?
क्या फिजिक्स पेपर में डाउट है? हाँ,
हाँ है।
डाउट मुझे भेज देना कि नेक्स्ट नेक्स्ट क्लास में जो डाउट होगा तो पहले वो सोल्व करेंगे।
हाँ, जो मैंने आपको 2 3 क्वेश्चन भेजा था वो भी करा देना थोड़ा।
हाँ, वो सबसे पहले करवाएंगे।
हाँ हाँ। एंड सर
ठीक है,
एग्जाम में नेगेटिव मार्किंग हो रही है, क्या करूँ?
नेगेटिव मार्किंग एग्जाम में हो रहा है? देखो,
हाँ
नेगेटिव
कल जैसे।
मार्किंग अगर हो रहा है तो उसका मेन रीजन ये है कि प्रैक्टिस हमने कम की है क्वेश्चन की। ठीक है, मतलब ऐसा नहीं हो सकता कि